right, I've got this very precarious setup here. Got about 6 books stacked up so that this camera will capture what we're doing. We're going to see how long it'll stay up. Okay, so the task here is to take this graph about the disease we looked at a bit in class called Kuru, and we're going to do what we call an annotation of this graph. An annotation means to take the graph as it exists and try to pull all the information out of it that we possibly can, and we add those meanings as notes on the graph. So we're actually going to write out what these things mean. So the first thing I do when I look at a graph is I see if it has a title, because that's the most obvious way to find out what the graph is about. Now this one doesn't, but I can kind of build my own title, because every graph is always trying to relate one thing to another thing, or one thing to multiple things. And the way I find out what this graph is about is by going to my axes. So on my x-axis down here, I've got time, and it says 5-year period. So when I look at the numbers along this x-axis, I can see that this is telling me in years. I start at 1957, and I run all the way over to 2001. So that's the whole span of time that this graph is covering. Not every graph is going to have time along the x-axis, so I have to make sure that that's what I'm looking at. And in this particular case, this graph doesn't do year by year by year. It does chunks of time. So I've got the first period is 1957 to 1961. So that's that first range right here, that first block. So each one of those blocks is going to represent 5 years worth of time. Okay, so now I know my x-axis. I'm going to go over to my y-axis, and my picture got a little cut off, so I had to kind of write in there. This says deaths from Kuru. So I have my background knowledge. We've talked about Kuru. I know that it's this brain disease that leads to people dying from paralysis. We've talked a bit about how you get Kuru. And now we're going to look at the trends. So I have to remember that this y-axis is not cases of Kuru. It's not how many people have been diagnosed with Kuru. It's deaths from Kuru. So what we're looking at is over the years, how many people are dying of this disease Kuru. And I look at my numbers on my y-axis, and I see that it just says 600, 700, 800, 900, 1,000. So the highest number I have here is 1,000. And I have to keep in my brain that 1,000 is the number of deaths from Kuru in a particular time period. So that's what my two axes are telling me. Over time, how many people are dying of Kuru. So if I wanted to give this a title, I might say deaths from Kuru, 1957 to, 2001. So I've given it my own title, just to remind myself that what I'm tracking here is how many people are dying from this disease as time goes on from the mid-50s to the 2000s. All right, so now that I know my setups, that was all just figuring out what this graph is supposed to be telling me, what it's going to be measuring, and then I have to look at what these scientists actually found. So I'm going to look through here and figure out what kind of graph they're using. So it looks like I've got a bunch of lines here. I've got this line, and this line. And I'm doing how something, deaths from Kuru, is changing over time. So it seems appropriate to me that they used a line graph, because a line graph is a really good way to show how things are changing over time. Are things going up over time? Are they going down over time? Or are they staying the same over time? And I've got lines that are all going down. So I can make my little notes here. So deaths from Kuru, and these are just notes from me. This is how I'm understanding the graph. Deaths from Kuru are declining over time. I'm going to keep it pretty basic for right now because I have all these lines are going down. If my lines were staying flat, it would mean there's no change in how many people per year are dying from Kuru. And if the lines were going up, then I would know that more people every year are dying of Kuru. But instead I have lines that are going down. So I know that overall the deaths are going down. Now if I take this top line, just because it's the one that jumps out at me first, I have to figure out what this line is because I've got 3 different lines on this graph. All right, so this is total. So I got to think, okay, what's my graph about? Deaths from Kuru. So this is total deaths from Kuru. So these are total people dying of Kuru every time period. So I would say, so my x-axis is every 5 years. Every 5 years, just to remind myself. So what I'm looking at here is I see these dots, and those dots are telling me that's the data that the scientists actually collected. So for any given dot, I can say, all right, that dot represents something they found out. So what do I know about this dot? Well, if I drop down here to my x-axis, then I know I'm like in the late 50s. They did a measurement there, because I would kind of draw my line down here and say, where does it meet up with my x-axis? So in the 50s, what we're seeing is 1,000, because I come over here. So I'm always looking at, whenever there's a dot on my line graph, where does it intersect with the x-axis and where does it intersect with the y? So here I'm noting that there were about 1,000 deaths total. And that was about 1957 to 1961. And then the next dot I see on this is over here. If I drop that line down, now I'm in the mid to late 60s. And in the mid to late 60s, if I come over here to my y-axis, it looks like just shy of 700. So about 700 deaths from Kuru. And that's for that time period. And if I keep following these dots, I'm going to see that as the time keeps going by, we have fewer and fewer total people dying of Kuru in every one of those 5-year periods. So that's for my total. So total, I have to make sure I know what total means. Because what are my other options here? I have a line that says age less than 20 years, and then I have a line that says males. So total equals all kinds of people. So in this case, total means adults, male and female, is my little notation there, plus children. And those are male and female. So if there is a human being that died of Kuru, it's going to be on this line. So I see that of the total human beings dying of Kuru, it's going down and down and down and down and down. And then I notice that my line kind of flattens out as I get out towards the 2000s. So for a while, it was dropping really fast. It went from 1,000 to 700 to about 500, and then a little more than 200. And then down here, if I look over here, this is maybe 50. So this is about 50 deaths as of the 80s and early 90s, and then it keeps going lower until it's almost at 0. So almost no deaths as of 2000. So this is good. Fewer people are dying of this disease. But these scientists didn't just give me the total deaths. They also broke down their data into subsets of the population. So this is all humans that die of Kuru. And then here I've got this dotted line that's telling me, okay, these are the young people dying of Kuru. So these are the teenagers and kids. Now, it doesn't specify male or female, so that must mean that they're defining this as male and female. So this is just, if you were a teenager or a child, whether male or female, that doesn't matter, you're captured on this dotted line. And so what I see, I do the same thing. I figure out how many teenagers and kids were dying of Kuru in the 50s, and I see that's about 350. So that's about 350 deaths. And then we're down to about 150 by the 60s, and then down to about 75 in the late 60s. And then by the 70s, I'm down here just about at 0, and then my line tapers off. So anytime I have a spot where a line intersects with either of my axes, I'm interested in that point. Because what that intersection of that line is telling me is that's the 0 point. That's when no more teens or kids dying of Kuru. Now I know humans are still dying of Kuru all the way into the 90s, but there's no more kids dying of it as of about 1976. So that's an important thing for me to note. So I'm going to say, just to be safe, by 1977, there's no more teenagers or children dying of Kuru. Okay, so I'm going to set that aside for a second. And then I've got a third line that says males, and it doesn't tell me their ages. So this means males of any age. And if I follow their line, I'll see it never started as high as the other two. So males never died of Kuru in the same numbers. And we kind of knew that from the story that we learned in class. So the males are not hit as hard by this disease. They don't die from it as often. But even so, in the late 50s and 60s, we had about 175 males, specifically, were dying of Kuru. And that line keeps going down and down and down. Now here's where things get a little tricky, where I have to keep track of what I'm looking at here. If I were to look at any given human being who had died of Kuru, I have to think of where that person might show up on this graph. So the simplest thing is to say, all right, let's say we've got a 10-year-old girl, and she died of Kuru. Okay, which line is she going to show up on? Well, the total tells me all humans dying of Kuru, all right? So if she's a 10-year-old girl, she'll be somewhere along this line. So if she died in 1967, she'd be, somewhere along here. So she's going to be in this line. Then I have to look at these other two. So these are people under the age of 20 who die of Kuru. If she's a 10-year-old girl, she's going to be on that line as well. So if she died in 1967, she's kind of down towards the end of things for, she's one of the last kids to die of Kuru, because after this point, we don't have any more kids dying of Kuru. So she'd be on this line too. The only line she wouldn't be on is the males line. Now, if we had a 65-year-old man who died of Kuru at some point, he'd be captured in the total. He'd also be within this population of the males, but he would not be on this line. So we're trying to look at this, try to figure out what's the story here, because every graph is actually telling you a story. It's just a different way of presenting it. Instead of telling it to you in words, it's basically pictures and numbers. So this graph is kind of complicated in some ways, because if you wanted to find out, so I don't see any line here that says females. So if I want to figure out how many females are dying, I have to look at the total number, and then I would have to subtract out the males. And so if I've got in the 50s, I had 1,000 people dying of Kuru, and about 175 of them were male, that means the rest of that total was all females dying of Kuru. If I wanted to know how many adults were dying of Kuru, I'd have to take the total and subtract out just the people under the age of 20. So for some kinds of information you might want to get from this graph, you'd have to do an extra step. It might not be jumping right out at you and already existing as a point along the graph. Now, the last thing that's kind of interesting to look at on this graph is these lines are all declining, but they're not declining at the same rate. So we have this big drop in the total cases, and then we level off. And then the males have more of a kind of just a slower, gradual decline. And then the deaths among teenagers and children drops off pretty quickly too, and it really bottoms out. So after 1977, you don't see any more children or teenagers dying of Kuru. You do still see adults dying of Kuru. So that's what our total line is. At this point, from the 70s onward, we do still see adult cases, people dying as adults of Kuru. So we have to figure out what happened here, why the kid cases went away so much faster. And that's another thing that isn't quite so obvious on this graph. And as you get more sophisticated with annotating graphs, this is the kind of really cool stuff that you can start to pull out. So no more cases in kids or teenagers after this point. That could mean a couple of things. That could mean either no more kids or teenagers are getting Kuru, so they're no longer being exposed to it, so we have no new cases of Kuru. Or, after this point, does that actually mean that since what we're graphing here is deaths from Kuru, there's no more kids or teenagers dying of Kuru after 1977, but what if they still are alive with Kuru after 1977? So let's say you are 16 years old in 1977. You're still alive. You've known several people that have died of Kuru, and you're 16 at this point. And then you keep living your life, and then in 1992, you die of Kuru, all right? So you were 16 back in 1977. By the time 1992 rolls around, you're not a kid anymore. So when you die of Kuru, you're not going to be captured on this line that shows children and teenagers, but your death will still be recorded as a Kuru death. So what this starts to indicate to us is that the disease was still out there in the population. And by 1977, we see the last child or teenager death from Kuru. But there were people that were children at that point, they just lived on to adulthood. And they didn't die of Kuru until later. They may have had it before that point, but this starts to get to how long does it take to develop Kuru? And it turns out that one of the trickiest things about this disease is that you get exposed to it through consuming the flesh, or the brain tissue specifically, of a person who died of Kuru, but it could take decades for you to develop the disease. It is a slow developing brain disease in a lot of people. So you may get exposed to it as a child and then not die of it until 30 years later. So this is why that strange situation where we hardly ever see cases of Kuru in adult men in this population, but that number is not 0. We don't see no cases of Kuru in adult men. 2% of the cases of Kuru in the story we were presented with were in adult men. We know that adult men don't eat the brain tissue of the deceased. It's not part of the cultural ritual. It would not be considered acceptable. So those adult men, those few adult men who died of Kuru in adulthood, they got exposed to it as children, as young boys or as teenagers who were still participating in that ritual. So you have to put together the whole story, the information that we were given beforehand about cultural practices, the statistics on who gets Kuru and who dies from it, and then these data that these scientists put together and graphed for us, and only then do we get a full and complete story of what's going on. So graphs are incredibly valuable tools in that road towards understanding a situation. And the more you can start to extract things and pull out meanings and do exactly this, annotate a graph. Don't look at it like some pristine piece of artwork that you just have to leave the way it is and you can't write on it. You should write all over these things. You should write questions. Who are these people? What does the total include? Am I sure I know what this axis means? What does it mean that this line is going down this fast, but this line is going down this fast and this one's flatter? So all those things that you have pass through your brain when you're looking at a graph, you want to put down in writing when you're annotating the graph. So your challenge in your next assignment is going to be to take some additional graphs that I give you guys and actually do this. Actually print them out or, write them out in some way and then do this. Write every one of your questions down, write down everything you think you understand, the shape of the line, the position of the dots, the y-axis, the x-axis. Does it have a title? If not, write a title for it. So this is a really good exercise because the more you can do this, the more powerful you become in the information and the knowledge that you can draw out of graphs that might have seemed too intimidating before. So good luck.